So yesterday we started talking about parallelograms. And at the end of the notes, we wrote a little list of things that we know are true. A few different colors here. When we see a parallelogram. So our list said, our opposite sides are congruent. Our opposite angles are congruent. That adjacent angles are supplementary. Opposite sides are parallel, and so we can use parallel line properties, and that the diagonals bisect each other. And so this little review will look very similar to what you'll be asked to do on the homework for parallelograms. And so notice that like my variables are here in angle Y and angle W, but it actually asks me to find angle Z. Okay, so there's going to be like several steps involved here. So it wants us to find angle Z. It's giving me Y and W, which are opposite angles. So what's true about our opposite angles? Oh, this needs to be turned around. What's true about our opposite angles?
Congruent.
They are congruent, yeah. Can't tell if that's backwards or not. There we go. So that means that 20x plus 1 equals 21x subtract 4. Okay, that they're congruent, they're equal to each other. So now I'm just going to solve for x. Subtract 20x. And 1 equals 1x subtract 4. Or x equals 5. Okay, so to solve for x, I had to know those angles are congruent. I solve for x. Now that I know what x is, I can plug that in and I can get what my two angle measurements are going to be. So what is 20 times 5? 100 plus 1 is 101. And it wouldn't matter which one I substitute in for. If I plugged in here, 21 times 5 is 105. Subtract 4 also gives me 101. Okay, which should happen. If I solved correctly, these should be the same angle. But it's asking me to find Z. So that's using adjacent angles, and we wrote on here. So our opposite angles are congruent. The adjacent angles are supplementary, add up to 180. So if we know that those angles that we had are 101, then what would angle Z be?
79, or sorry, 79.
79 degrees, yeah. So I have to use kind of several properties to get to the measure of angle Z is 79 degrees because these are same side interior angles and they're supplementary. And you'll see that in your homework as well. Like you have to pay attention to which piece is it actually asking for. On the next one, it just asks us to find X. And so it tells us that RD, so RD would be here. That this length is 22. And then it says BD would be the whole length. Okay, that the whole length of that diagonal is 4 plus 5x. Okay, so in terms of labeling what it gave us, RD is 22 and B to D, this whole length, is 4 plus 5x. Okay, well, what did we learn about our diagonals? What do they do? The diagonals are congruent, they're being bisected, meaning that if this is 22, then this is 22. Okay, so if I know that this length is 22, I know that this length is 22, or in other words, I know that 4 plus 5x has to equal 44, because 22 and 22 together is going to give me 44. Or 5x equals 40 and x equals 8. Okay, The next one is a little bit tricky. It gives us our angle up here kind of broken into two parts. But given where our x and our, like we have an x here, we have an x here, we're gonna end up having to use these two angles anyway. There's kind of a few different ways that I could get there. So we know these lines are parallel. And so this whole angle T and this angle S together have to add up to 180 because these are same side interior. So all of this together, not just a piece of it. The other way that I can look at this and get kind of the same equation is that I do have alternate interior angles. So if I have 48 degrees here, I have 48 here. And if I have 11x subtract 4 here, then I have 11x subtract 4 there. Okay, so I can also use alternate interior angles, or I could use that my opposite angles are the same. And then another way that I could get the correct equation is using the triangle there. Okay, so another thing I know is that alternate angles are the same. Okay, so then all of this has to add up to 180. It's the same numbers, the same values adding up to 180, whether I think about the fact that this has to add up to 180, that this whole angle plus this angle, or that this triangle has to add up to 180. However you get there, you end up with 11x plus 4 plus 48 plus 11x subtract 4 equals 180. And so let's see, plus 4 minus 4 is going to cancel out. I'm going to have 22x plus 48 equals 180. And subtracting 48, we get 22x equals 132. Divide by 22. And x equals 4. No, not 4. 6. Oh, I didn't even want to mark that. That's okay. So I found x. X is 6. I'm not done though. It didn't ask me to find x. I had to find x in order to answer the question it was asking, which was to find RTU. So RTU, R to T to U is right here. It's that angle. So angle RTU equals 11x subtract 4. It's this angle right here. So now I know that x is 6. So I have 11 times 6 minus 4, or 66 minus 4. And angle RTU is going to equal 62. Okay. And our last one, going over those concepts that we learned yesterday, what's true about my opposite sides for a parallelogram? Here I have EH and GF. What's true about my opposite sides? Opposite sides are congruent. So I know that EH and FG are the same length, or that 4x plus 5 has to equal 5x plus 1. Subtracting 4x, 5 equals x plus 1. Subtracting 1, x equals 4. Well, great that x equals 4, but we need to go back and answer the question, which is find GF. GF is here. What would GF equal if x is 4? What would GF equal? 21. I think you subtracted one maybe instead of adding one.
Oh, yeah.
21. Okay, good. So now we're just going to kind of look at some if-then statements with our parallelograms. Because like I said yesterday, there's all sorts of quadrilaterals. Only certain quadrilaterals can be called parallelograms. And so how would we know if it's a parallelogram or if it's not? Okay, how do we know? Or how do we prove? And again, we're going to say, well, if this is true, then it's a parallelogram. Okay, if this is true, then it has to be a parallelogram. So there are certain things we know are true, but it doesn't necessarily make it always a parallelogram. If a couple of things are true, sometimes only one of those things you need, but if a couple of things are true, then that's enough to say it's a parallelogram without knowing all of those properties we listed yesterday. So one way that we could know that that our quadrilateral is a parallelogram is that both pairs of the opposite sides are congruent, then it's a parallelogram. So if I knew that these sides were the same, and I knew that the other opposite side pairs were the same, that's enough to say, okay, then it fits the parallelogram and it has all the parallelogram properties as well. Okay, and that's why we care about saying this, because, oh, okay, it's a parallelogram, that means opposite angles are congruent, adjacent angles are supplementary, the diagonals will bisect each other. I'll know all of these other things about the shape. Okay, so one way to know it's a parallelogram is if the only thing I'm told are that opposite sides are congruent, that's enough to say it's a parallelogram. One that's not listed here, I'm not sure why, so I'm going to call it 1B. If both, has to be both sides, not just one side. Sides are parallel. Okay, so if, just like that one, if I'm told both sides are parallel to each other, opposite sides are parallel to each other, then that's enough to know it's a parallelogram. It wouldn't be enough if I just knew one pair of opposite sides was parallel, or it wouldn't be enough if I just knew one pair of opposite sides are congruent. I need the both there in order to say it's a parallelogram. However, if I knew one side, just one side was congruent and parallel, okay, so here it's just one side, up here it had to be both. If one side is both of those things, then it has to also be a parallelogram. Okay, then that's enough to know it's a parallelogram. Again, the next one, it has to be both, but if I knew that one set of opposite angles are congruent and the other set of opposite angles are congruent, that's enough to know that it's a parallelogram. And last, anytime we have a quadrilateral and it shows us that the diagonals bisect each other, meaning that this is cut into 2 equal lengths and the other diagonal is cut into 2 equal lengths. Okay, anytime that's true, then it must be a parallelogram. So the way that we will use this, you'll see in homework and quizzes and whatnot, is just determining, is it a parallelogram or is it not? Or do I have enough to say that it's a parallelogram or not? So on the first example, I'm given information about my diagonals. So I'm being told that I have 9 and 9 and 12 and 12. And I can say, yes, this is a parallelogram because it shows me that the diagonals bisect each other, or that's number 4 up above. Okay, I don't need any other information. If that's true, it must be a parallelogram, and therefore all those other things are true about it. On our second parallelogram here, it's a little trickier to see what it's giving us. So it shows 24 and 24, so I know that this side is congruent to this side, but knowing just one side is congruent to the other opposite side isn't enough. I'd have to know both. But you'll notice that it also gives me these angles. Now these angles are alternate interior angles, okay? Which means if my alternate interior angles are congruent, going back to parallel line proofs, if this, then parallel. So the reason they're showing these angles is that's going to tell me that this line is parallel to this line because my alternate interior angles are congruent. Okay, now the reason that's there is because that's number 2. I can say that this is a parallelogram because one pair of opposite sides are congruent and parallel. This is reason number 2 up above, okay? If one of my opposite sides are both congruent and parallel, it must be a parallelogram. On my third parallelogram, I'm told 65 and 65. Now I don't know if these lengths are the same. I don't know if this is parallel, so I have no idea what this angle is. So do I have enough to say that? No, I don't. It looks like one, but I don't have enough to say that it's a parallelogram. I only know that one pair of opposite angles are congruent. Put your cell phone away, please. I need to know that both pairs of opposite angles are congruent. So this is no, we don't have enough info. Not enough info. The last one, again, we can use, we have alternate interior angles here. So here and here are alternate interior angles, or here and here. And so if I have alternate interior angles going this way, that shows me that this line is parallel to that line. These alternate interior angles would show me that those two sides are parallel, and that's the one I added in. So I either know that both my sides are congruent, opposite pairs are congruent, or if I knew that both pairs of opposite sides are parallel, then that's enough to know that they are, that's a parallelogram. So yes, both sides, both opposite sides are parallel. That's number 1B up above. Okay. So I hope that's all I have planned for today. I think that's all I have planned for today. Yeah. Okay, so tomorrow we'll go over the first homework kind of uses this info. We have these properties of parallelograms. It's very similar to what we did at the beginning of class today. Don't do the back side of this where it just says parallelograms worksheet. We'll do that together over Zoom tomorrow. Okay. Well, I'll see you on Zoom tomorrow and have a good 5 days home before I see you again. When you're ready, you can stand so that I can clean that.